Alright, so we'll now talk about our next and the last addressing mode. Remember in the last lecture we talked about the relative addressing, right? And we know how it looks and how you calculate the relative addresses. Now this is actually the last addressing we have in our plate, which is actually index addressing. To understand this, I'll start with an example first to see how these instructions are completely different than what we have seen so far. Then you can realize that, oh, we have still something left in our plate. Let's see. Now look at this instruction here. We have 3 lines, very simple 3 lines. If you look at the instructions, you see in the left side we have LDX in the first line, second line we have LDAA, we have ADDA. All this looks similar. I'm saying looks familiar, right? But look at the right side in the second line and the third line. Do you see something different? Look at this. Look at how we wrote it. We wrote some number, right? Something like a hex number and a comma and an X. But now, if you look at this one, you actually don't know how to calculate the object code, right? Meaning, how is this an address or is this what? We don't know it, right? Because in general, we just know whether this is an address, this is a data or something, right? So these kind of instructions are actually called indexed addressing. Okay, whenever you will have something like comma X or comma Y, because X and Y's are actually the index register. Okay, now let's see how we can understand these. These are actually equivalent to some other lines. So let's see how we can decode it and understand what we have to do here. Now to understand it, first understand these. If you have any instruction like this, you'll realize it right away, right? I'm saying it will be like comma X or comma Y with an instruction. So if you have anything like this, you actually have to calculate the operand. How you calculate it? You will calculate using a formula. This is the formula. The formula tells the operand equals to base address plus displacement. Now what is the base address? Or what is the displacement? Okay, we don't know it here. Now this is actually the base address. That means base address will be always the content of the index register. It may be index register X, it may be index register Y, depending on how it is given. Meaning, if it is like comma X, that means it's the content of the index register X. If it is comma Y, that means it's the content of the index register Y. Okay. Now we know how we get the index register. I'm saying the base address, right? This is pretty straight. So that's so now we know about the base address, but how we get the displacement? Displacements are actually these ones. Look at I just circled the displacements. That means for the line 2, if you look at the line 2, we have the displacement is actually 25. So that means this number here is actually a displacement. It's not the real address. Okay, it's not an address. It's not a data. It's a displacement. So that means for line 2, the displacement is 25. For line 3, displacement is 34. Be careful. You have to everything have to be in hex, right? For these lines, we have everything in hex. If it is not in hex, if it is in decimal, if it is in binary, convert it back to hex. I'm saying we always do it, right? Okay. Now, so let's say for line 2, how we calculate the operand? What is the formula? Let's go back to the formula here at the very top. What is the formula? The formula is base address plus displacement, right? So if I calculate for line 2, this is what we get, right? For the line 2, your operand is going to be, this is your base address, right? 0040, and this is your displacement, right? We just add, just hex addition. Once we add it, 0065. That's your original operand of the line 2. Okay? And for line 3, base address is still same, right? Because that's the content of the index register, but the operand is different, right? It's 34. If you add them, this is 0074. That's the actual address of the line 3. Now, if I know the real operand of line 2 and line 3, I can actually write this 3 line to this 3 line on the right side. Do you understand everything you have in the right side, right? 3 lines. Do you see what I'm saying? See, I just replace this 25 comma x by 0065. Because that's what I got here, right? From the operand. Okay. And for the line 3, I got I'm saying just by I'm replacing $34 comma x by 0074 because that is what I got here calculating the operand. Right? So now once we do this, pretty much you understand what we need to do, right? Because now if you check the line 2, I'm saying the second side, I'm saying the right side 3 lines, we understand pretty much what we need to do, right? Because this is an address here. This looks like what? An extended mode instruction, right? And you understand what we need to do, right? We have to load something from the memory location 0065, right? Into accumulator A, right? In the third line, we'll be adding something from address 674, right? Whatever the content of 74, we'll be adding with A, right? And I think we understand all of it, right? So this is what you will have in index addressing, meaning anytime you have an instruction given in index addressing, you actually have to calculate the real operand just by adding the base and displacement. That's it. Now let's look at a couple of quiz questions, okay? So that we understand it a little bit better. Now let's say if somebody asks you this, which memory location is addressed by line 2? Okay? Now look at the line 2, you'll be actually given the code you have in the left side. Because those are the index addressing. All you have to do is just add the base plus displacement, okay? So the answer is 0065, right? For the line 3, again you'll be adding the base plus displacement, right? Which is 0074, right? That's your answer. It's a very straight answer, okay? So if you are asked, but it will depend on the line, right? I'm saying each line will have a different displacement, so it will have different answer, right? Because even if the base is same, but since the displacement is different, so the operand or the memory location address will be different. Okay, now let's look at an example. It's a little bit more extended example. I have 4 lines here, right? If somebody give you these 4 lines and ask you, okay, can you calculate the displacement? I'm saying not the displacement. The memory location is which memory location is addressed by line 2 and line 4? Again, we'll go by the same formula, right? The base address plus displacement, right? That will be the address, memory location address. So to get the line 3, so you can always convert it back like this, right? Let's say 007A. So what I did is this: for line 2, the base is what? 007A, right? And displacement is $15. I just add them. It's a very straight one, right? But notice the line 4. There is a little catch here, okay? Why the base is changed? Do you see I marked it red? It's not 7A, it's actually 7B. Why is that? Because by the time you go to line 4, look at the line 3. INY. And that actually changed the content of index register Y, right? Do you see how base can be also changed? So you need to be a little bit careful because it's not always what you have at the first line, okay? Because in the middle, your base can be changed because anytime your content of the index register is changed, that means your base is changed. So because of the line 3 here, because I and Y basically add 1, right? With the content of the index register Y. So that's why in the line 4, your base is actually changed to 7B, not 7A here. So be careful, sometimes base can be changed, right? Now once the base is changed, your displacement is what? 65, right? Do you see the displacement 65? I converted displacement to into hex. As I always do, right? As we always do, into 41, which is 65 actually in decimal. So I just calculated the operand, just adding the base plus displacement, right? But be careful, the base is 7B and the displacement is 41, right? And that's how I got the answer for the line 4. So be careful about these, that your base can be changed anytime if your content of the index register Y or X, whatever, is changed, okay? Any question here? Okay, this was, I think, a nice exercise. Let's try another question here, okay? Now, let's say I have the same question here again, but I changed the question. Now, what is the question here? Let's read the question together. Now, what we are asking is, what data is loaded into accumulator A, I'm saying accumulator B, by line 2? Again, we have all the 4 lines here. To understand it, we first converted this to, all the 4 lines you have in the left side. We convert it to all the 4 lines we have in the right side. I think we know how to convert it, right? Just adding the base plus displacement, right? Once we do it, let's look at the line 2. What we are doing in the line 2? We are loading something from address 8F, right? We are loading something from address 8F into accumulator B, right? So where is 8F? This is 8F, right? I circle this one here. So that's your answer then. So you will be actually loading F2 into accumulator B, right? Let's look at a different question. What will be the content of accumulator B after line 4 is executed? That means at the end, right? So what you are actually doing, if you convert all these 4 lines, you actually can see what you are doing, because you have 8F, which was F2. You loaded F2 into accumulator B, right? In the 4th line, you will be adding, you will be doing a subtraction, and the subtrahend will be coming from here, right? From BC. Now, where is BC here? I circle both, right? So this is what you loaded at the beginning, which was F2, right? And you'll be subtracting BC, right? Which is AF. BC is an address, right? So after the subtraction is done, your answer will be this, right? F2 minus AF is 43. No, these are the simple, as you can, but remember in the question, you'll be given actually the 4 lines you have in the left side, right? So you actually have to convert it to the right side, all the 4 lines. Once you convert that, all the answers should be pretty similar that you have done before, right? Any question here? Because once you convert it, you will actually have pretty much the lines you have seen so many times, right? By now. Okay, now if we understand up to this point, we are actually done for the index addressing, because this is pretty much just the converting. Whenever you have something comma X, it's just like converting into a real address just by adding the base and displacement. Okay. Now let's go to the quiz section very quick, and then try working on quiz 18, 19, and 20. So actually the 18, 19 is mostly based on the index addressing. In the 20, you will have something mixed up from the previous ones and here, because every time we learn something, we actually add them with the previous things what we have learned by now, and then we combine them, and we want to see everything together, because what you are learning is not like a separate thing. It's basically the continuation of whatever we have seen by now. Okay. Let me stop the presentation here for today.